Hello dear student, good morning. Welcome back. Ninth B Science 1 chapter number 3. Today we'll cover 4 topic, 2 small topic, 2 big topic. With small and simple circuit, we have to check the substance is conducting substance or non-conducting substance. Means through which electric current can pass or can not pass. So through which electric current will pass, that is a good conductor of electricity. Through which the electric current cannot pass, it is a bad conductor. One source they have not given, you can draw here. E for energy battery, K for key plug switch, A for ammeter. This is a gap, A terminal, B terminal. It is not connected. This is a bulb. Now take 4 different rod. Take copper, wood, plastic and aluminum. 4 different rod. Connect copper rod, so it will connect from A to B. Now switch on plug switch. Bulb will glow because it is a metal. So copper is a good conductor of electricity. Bulb will glow. Now remove copper. Joint wooden part, wooden piece A to B. Now bulb will not glow. It is a not conducting substance, non-conducting substance. Through wood, electric current cannot pass. Now remove that. Joint aluminum rod, A terminal, B terminal, here A, here B. Bulb will glow. Whenever you will connect metal, bulb will glow. So it is a good conductor. Remove. Replace by wood or by plastic or by glass rod, A terminal, B terminal. Bulb will not glow. Only for metal rod, bulb will glow. This is incomplete circuit. We have to complete by applying some rod one after another to check that it is a good conductor or bad conductor. Copper, it is glowing, good conductor. Aluminum, good conductor. Iron rod, bulb will glow, good conductor. Then wood, not glowing, bad conductor. Plastic rod, A, B, not glowing, bad conductor. Glass, bulb is not glowing, bad conductor. Like that, from this very simple circuit, you can check it is a good conductor or bad conductor. Simple. Next, for that, see, this is plus. So from plus, here when you will apply some substance, this rule. So positive, it is positive. Negative, it is negative. Like that. Big line always positive, small line always negative. So positive, 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 negative, 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 negative. Now always flow from positive to negative. When it is close. Symbol V for voltmeter, potential difference it will measure. A for ammeter, electric current in ampere it will measure. K, plug switch on off, when dot is there means on. E for energy, only one part is there, so that is a cell, and if more than two, more than one, two or more than two, then it is a battery. Now when we start the electric current, this ammeter also will fluctuate and voltmeter also will fluctuate. We have to measure. Suppose it is 100 volt. This is 10 ampere. So 100 by 10 is equal to 10 ohm. Suppose it is 200, 20, again 10, 300, 30. So when you will increase voltage, potential difference increase, current also increase. So both will increase simultaneously, both will decrease simultaneously, and the ratio always will come constant. So V by I is constant, and that we denote by R. So V is equal to IR. Any formula you can use for the numericals. Ohm's law. Ohm's law. In a circuit, the ratio of potential difference between two terminal and the current passing through that two terminal will remain constant, and that constant is known as resistance. So V, voltage, potential difference, we measure in volt. I, electric current, that we measure in ampere. So voltage by ampere, whatever the ratio, constant ratio you will get, this increase, this increase, this increase, this increase, this increase, this increase, but the this by this, this by this, this by this, always it will be same answer if you will not change the resistance, or if you will not change the conducting wire. So this ratio always constant. This is the Ohm's law. What is the Ohm's law? When a electric current passes through the conductor, the ratio of potential difference and electric current will remain constant. That is resistance. In the resistance, we measure it, means the unit of resistance is ohm, OHM, and the sign is like this. So V I R, voltmeter, and we will write voltage. Okay. Voltage, ampere, resistance. V, voltmeter, voltage we will write symbol V. I for A for ammeter, and that we will measure in I, current. R is resistance, that in resistance, what are the symbol? The symbol will be the same. Symbol will be the same, but here the symbol is like this, like this, like this. This is called ohm. When it is 1 ohm, V is equal to I, V by I is equal to R, or V is equal to IR. When this is 1 volt and when this is 1 ampere, it is said to be 1 ohm. So when it is said to be 1 ohm, when electric current passing through the conductor is 1 volt, the potential difference between two terminals is 1 volt and the electric current passing through the wire is 1 ampere. At that time, the resistance is 1 ohm. Or reversible, you can say, when a current passing through the conductor is 1 ampere and the potential difference between two terminals is 1 volt. This is potential difference, this is current. Current is 1 ampere and potential difference is 1 volt. At that time 1 ohm. Or ulta, if the potential difference between that conductor, 2 point of the conductor is 1 volt and the current passing is 1 ampere, at that time the resistance will be 1 ohm. So first part done, second part done. This is a small part, this is a circuit. Through this circuit we can identify that different 3 road, 4 road I am taking, see, of different color. I have to fill this gap, means two terminal will be touched. So if bulb will glow, it is conducting. If it is not glowing, non-conducting. Then next, to measure ohm, the resistance. Third, this resistance we can increase, this resistance we can decrease by using special type of the circuit. That two type is RS, RP. RS, R for resistance, S for series. RP, resistance in parallel. In textbook, they have given very lengthy and individual. This we will study parallel, RS, RP. So you will get the main point, you will get the distinguished point, and both the topic will be clear very easy. basic structure of the circuit. This is the basic structure. Now who is opening mic and video? See, this topic is very important for a long question. Short note, distinguish, formula, numericals. This is the very cream part of this chapter. RS resistance in series, RP resistance in parallel. So A meter, E for energy, battery, K for key switch. Now resistance are in series. So 1, 2, 3. This is the resistance. R1, R2, R3. Correct? And symbol already filled on. So here there is a voltmeter. Resistance in series, and now resistance in parallel. These three resistance are in series. These three resistance are parallel. Geometrical. Series, parallel. Voltmeter across resistance. Step number 1, first draw the basic part in both. Part number 2, resistance in series, and to any one resistance you show voltmeter. Here you show this three resistance in parallel and across that voltmeter. This is second part. Third part, symbol are based on battery. Long line always positive, short line negative. Always positive, negative. Now positive touch to whom? All are positive. Positive touch here, positive. Positive touch here, positive. Only voltmeter and ammeter you have to show the sign, not rest. So negative, negative, negative. Negative, negative, negative. And one is positive, opposite naturally negative. But officially how it is? Positive touch, positive. Positive touch, positive. Negative touch, negative. Negative. Now flow. First part diagram, then second part resistance, third part sign. First part what we have drawn, basic diagram. Second, RSRP. Third, symbol. Fourth, direction. From plus direction. From plus direction. Wherever it fold, you show the direction. This side. Is it visible? Green number, green color visible? Hmm? Now visible. Now visible. अरे अभी विजिबल है, मैंने ब्लू किया ग्रीन का. साहू को मम्मी डांट रही है क्योंकि वो ऑनलाइन करके सो रहा है. वेरी. हाँ, नेक्स्ट. फर्स्ट बेसिक डायग्राम, then show resistance in series and parallel, then show the symbol, then show the direction. See, from if your diagram is correct, now this all things will be correct. Very easily you can judge the answer of this. Okay. This is the instrument which will measure the potential difference. Don't take this as a part of the circuit. So here potential difference different, here it will different, here it will different. For all three, V is different. Here for all three, V is same. Now we thought about V. Now we think about I, current. Current from the battery will pass. It has only one direction. No another way. Means I, V, current, electric current, I, through the ampere, ammeter. It is a constant. Here, current pass through this, it can pass through this. It can pass through this, it can pass through this. Flow of current has three options. Here voltage have three options. Here V is constant. So what is constant? RS. In RS, I is constant. In this, V is constant. V will not change. Here I will not change. Here V will not change. In series, potential difference is will change, and current will be the same. Here potential difference will be the same, current will be changed. So from the diagram, see here V different, I same. So I is constant, V is different. V same for all three, but I see one circuit, two circuit, three circuit. So first that you have to recognize which is constant, which will change from I and V. So which is constant, for that we cannot write the formula, but which will change, for that I can write the formula. If V will change, so V is equal to V1, V2, V3. I is equal to I1, I2, I3. What will change? Write the formula of that. If V will change, here V will change, so V1, V2, V3. Here current will change, so current 1, current 2, current 3. I is equal to I1, I2, I3. This is for S, so we will write Vs. This is for P, parallel, so I will write IP. And in previous topic we learned V is equal to IR. So all we will write V is equal to IR, V is equal to IR, IR, IR. and V is constant for all. So resistance 1, resistance 2, resistance 3. I same, so remove. So RS series is equal to R1, R2, R3. Which is constant? Which will change? That will change. Write the formula for that and convert it into the Ohm's law. And what is the constant? Remove. Which is same? Which is change? Which is change? Write the formula, and V is equal to I is equal to what? V by I. So all V by R, V by R, V by R, V by R. Because V is constant. So V cancel. So it is 1 by R parallel, 1 by R1, 1 by R2, 1 by R3. Now, sum of three number by adding always increase. So to increase resistance, reciprocal, 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 and addition of reciprocal, decrease. So resistance, I will write R. Resistance increase, resistance decrease. When resistance increase means obstacle increase, so what will decrease? Current will decrease. Resistance decrease, obstacle decrease, current increase. So I write I ulta. Increase, decrease, decrease, increase. So this type of the circuit where we will use to decrease the current. Here increase the current. Here where we use to let me introduce full, because it is 3-page given full on instruction, and that you will not understand, because when you will learn both parallel, then only you will come to know that exactly what it is. What is RS, what is RP? RS resistance in series, RP resistance in parallel. Basic diagram, RS3 in series, 3 in parallel. Then write the symbol plus and minus. Then from plus to minus show the direction. If symbol wrong, full diagram wrong. If direction wrong, full diagram wrong. Like maths, you cannot say this much is correct, give me this mark, this much is correct. In a circuit, if there is a single very silly mistake, it will short, it will fire, it will blast. So symbol and direction should be 100% accurate. If anything is wrong, full diagram is wrong. Consider that it is a blasting diagram. Don't use it. It is very dangerous. Away from this type of the highly inflammable project which are prepared by you. Basic diagram, then draw resistance, then draw parallel voltmeter, then write the symbol, then give the direction. For your understanding, I use color, but in the exam you will draw this all by pencil only. All the points, symbol, direction, plus minus, indication, all with pencil, no pen. Now here you can see current is constant, I is constant, V change. Here ulta, right ulta. What will change? Write the formula. V is equal to V1, V2, V3. I is equal to I1, I2, I3. Then V is equal to, as per the Ohm's law, that in previous topic we have learned, V is equal to IR, V is equal to IR, and I is constant. So I will remove I. So I is equal to V by R, V by R, V by R, and V is constant. So remove all V. So these are the basic formula. When they will give R1, R2, R3 values, they'll ask to find out in series how much it is, in parallel how much it is. When you will add, no, it will increase. When that same three number, you will take the reciprocal, you will add it, it will decrease, it will less than individual. Suppose it is 5, 10 and 15. You will get the answer less than 5. Overall answer is less than all three, rest of three. So resistance increase, current decrease. Resistance decrease, current increase. So where we have to decrease the resistance and increase the current, and where we have to increase the resistance and decrease the current. This is a mobile charger 2-pin. This we connect with 240 volt. In residence it is 240. In commercial 440. In an industry 840. 240, 440, 840. At home this 2-pin will catch 240 volt. And then one USB we connect with the mobile. Mobile need 5 to 7 volt. So inside this box there is this. If 240 volt will pass from here, with this resistance it decrease. With this resistance again it decrease. With this resistance again it decrease. And to your mobile it will pass only 5 to 7 volt. So in charger, adapter, we use this series to decrease the current. For Casio piano, for transistor, tape recorder, we need less volt. So at that time with the cord which we are using, it is done with this. So inside there is a circuit which reduces the current. That is why the second end of, when you will connect this and the second end of the point you can touch, very less current. But after joining this, here you can not touch. Here we are decreasing. Sometime on a road or in the subway or somewhere, the water is overflowing due to the heavy rain. At that time they want to pass this water from here to here by that motor. So they wind the thread with to the wheel and they stretch it. So it will start moving. Generator I am talking about. So slowly current will increase. Multiplier. So when we decrease the resistance, because whatever the electric current will pass, suppose it will pass 5. So it will pass 5, but this is a resistance. It will just pass 3. 5 volt, it will pass, decrease 3. 5 it will pass, again it decrease 3. So all 3 will decrease, but all 3 will give 3. Here you will get 9. From all 3 it will pass, from all 3 it will decrease, then it will collect at one point. So it will increase. Students are coming, going, what it is going on. So this is the resistance in series and parallel, which are the point we have discussed. That is on page number 38, 39, 40, 41. That much is there in this chapter. Which is constant, which is varies, which will change, which is change, that you have to write the formula. In that formula you have substitute this Ohm's formula, replaced by Ohm's formula, and again what is constant, remove, so only R will remain. These are the direct total, these are the reciprocal total. Direct total always will increase, means greater, and reciprocal total always will decrease, and it is less than the individual. So when resistance increase, current decrease. When resistance decrease, current increase. This to use to increase. First circuit resistance increase, so we use this to decrease the current. This decrease the resistance, so we use this to increase the current. Transistor, adapter, generator, motor are the example. So today we have completed simple circuit. By that we can identify it is a good conductor or bad conductor. Second, we have learned how to measure resistance by Ohm's law. Third and fourth, that is resistance in series and resistance in parallel. These two are very, very, very important, and out of two, one long question or the distinguish between two, 101% will come. Okay.